Hello everyone. In this video, I am going to one of the combinational circuits examples, that is encoders. Okay. So other than with encoders, we know the other combinational circuits are half adders, full adders, half subtractors, full subtractors, magnitude comparators, decoders, encoders, multiplexers, and demultiplexers. In this video, my concentration is about encoders. About other examples, I made some other videos. Okay. Let's start about introduction about encoders. So as of now, we know encoder is a combinational circuit. It has the maximum of 2 power n input lines and n output lines. So it is a encoder. The maximum number of inputs are 2 power n and n outputs. So here n is this power of 2. It will produce, what is the function of that encoder is, it will produce a binary code equivalent to the input. Binary code equivalent to the input, which is active high. We will go for in detail about that concept. Therefore, it encodes 2 power n input lines with n bits. So it encodes the 2 power n input lines with n bits. So that is the introduction part of that encoder. So how to represent that encoder? So simply whatever just now I indicated that diagram, the same diagram. Now see, now here it is the encoder. It consists of 2 power n input lines and n output lines. It encodes 2 power n input lines to n output lines. So it is also known as binary equivalent. Binary equivalent. We will go for some examples. So at starting, now I am considering 4:2 encoder. So how we can write that 4:2 means 2 power 2. So is to 2. So that means here n value is 2. Therefore this output contains 2 and number of input lines are 2 power 2. That means 4 lines. The same thing. So in 4:2 encoder, it consists, see, there are total of 4 inputs. Those are y0, y1, y2, y3. And 2 outputs. Those are a0, a1. So in 4 input lines, one input line is set to true at a time to get the respective binary code in the output side. Out of these 4, only one at a time acting, that will be forwarded to output side. So the block diagram and corresponding to table and its analysis part is shown in the next slide. So now see the block diagram. So 4:2 encoder, 4 inputs y0, y1, y2, y3, and outputs are a0, a1. Okay. So it is the black diagram part. Then it's a two table is, now see, inputs are y0, y1, y2, y3. Inputs are y0, y1, y2, y3. And their respective outputs a0, a1. Okay. at a time. Now you can observe the first possibility is 1 0 0 0. Next one 0 1 0 0. Next one 0 0 1 0. Fourth one 0 0 0 1. By observing all these combinations at a time, only one input is high. Only one input is high. Now see in first one, so y0 is high here. In second one, y1 is high here. In next one, y2 is high. In next one, y3 is high. So that outputs representing their equivalent binary value. So now for this one, because of y0 is active high, therefore its equivalent binary is 0 0. Here y1, its equivalent binary is 0 1. Here y2, its equivalent binary is 1 0. y3, its equivalent binary is 1 1. Once truth table is formed, then from these outputs we will write the corresponding expression for A0, A1. Now observe, A0 is active high for A0 is active high for input Y, input Y1 and input Y3. So therefore from here A0 is simply Y1 plus Y3. Next, similarly, A1 is active high for Y2 and Y3. Therefore, it is active high for either Y2 or Y3. Y2 or Y3. So the same expressions here. Now see, A1 is active high for Y2 or Y3. A0 is active high for Y1 or Y3. So by using these two expressions, then I will show the corresponding logical diagram. So A0 is simply addition of Y1 and Y3. So now see A0, it is addition of Y1 and Y3. So for addition simply OR get. Next A1 is addition of Y2 and Y3. Addition of Y2 and Y3. So therefore it is A1. It is A1. So the first diagram indicates a diagram, second one is truth table, and third one here it is the logical expressions, and fourth one it's a design diagram. The same concept it can be extended for that 8 to 3 encoder also. 8 to 3. 8 to 3 it can be represented as 2 power 3 into 3. So 8 is, so output number of outputs consists 3. So that one now I am going to be explained. 8:3 encoder, the next example. Okay, so now see, the 8 to 3 line encoder is also known as, because of 8 inputs, this one is calling as octal to binary encoder. 8 indicates octal. 8 indicates octal here, therefore it is called as octal to binary encoder. Anyway, in 8 to 3 line encoder, there is a total of 8 inputs. There is a total of 8 inputs. Those are Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. These are the inputs. And their respective outputs are A0, A1, A2, A3. So 3 outputs and 8 inputs. 8 inputs and 3 outputs. In 8 input lines, one input line is set to true at a time to get the respective binary code in the output side, like as same 4:2 encoder. So the block diagram representation of 8:3 encoder is shown in figure. So now see totally 8 inputs and 3 outputs. Okay. So next I will show to you the corresponding truth table. So now see truth table. So inputs are starting from Y0 to Y7 like as in sequence Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. Now those combinations at each time only one of the input is active high. In first case Y0, in next case Y1, next Y2, Y3 like that. In last case Y7. The outputs represent their respective binary value. So here Y0 is active high, therefore their respective binary value is 0. Here Y1 is active high, so 1 in binary form 001. Here Y2 it is in binary form 010. Here Y3 3 is in binary form 011. Here 4 in binary form 100. Here 5 in binary form 101. Next, here Y6, 6 in binary form 110. Finally, here Y7 in binary form 111, 111. Anyway, the logical expressions for A2, A1, A0 are as follows. At first one, A2. A2 is active high for 4, 5, 6, 7. See, active high for 4, 5, 6, 7. Therefore, A2 is Y4 plus Y5 plus Y6 plus Y7. Next, like in the same manner, A1 is active high for 3, 4. It's a small mistake. A1 is active high for not 3, 2, 3, 6, 7. 2 here, 3, 6, 7. In the same way, A0 is active high for Y1, Y3, Y5, Y7. Therefore, their respective equations are shown here. Then we will go for the corresponding design diagram. The same equations of A0, A1, A2, their respective diagram is. So now here see A2, it is A1 and A0. Simply all these outputs are coming from OR gates. For these OR gates, inputs are their respective inputs. Okay, so here these OR gates are 4 input OR gates. Okay, simply A0 is now it is Y1, here it is Y3, here it is Y5, here it is Y7. Finally, Y1 plus Y3 plus Y5 plus Y7. Okay, so it is the logical design diagram of that 8:3 encoder. Okay, so up to now we covered 4:2 encoder and 8:3 encoder. This can be represented as 2 power 2:2. It can be represented as 2 power 3:3. So now by observing this, in these two examples, the number of inputs are 2 power n. So that is the maximum number of inputs. Maximum number of inputs. sometimes inputs are less than its maximum number. Less than its maximum number, that is less than 2 power n. Less than 2 power n. Now we will go for one of that example. For suppose with four variables, the maximum number is 2 power 4, that is 16. But we are not going for with 16 inputs. We are going for less than 16. For example, with 10 inputs. So here 10 is magic number. So we know that is the base of decimal numbering system. That's why it is the number of inputs for an encoder is exactly equal to 10. Then it is calling as decimal. Okay, and then output it shows with outputs are 4 outputs. The number of outputs are 4. So finally that respective encoder is decimal to BCD encoder. So now see, in 10 is to 4 encoder, there are total 10 inputs. Those are Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7, Y8 and finally Y9. And 4 outputs, those are A0, A1, A2 and A3. In 10 input lines, one input line is set to true at a time to get the respective BCD code in the output side. Okay. Next, the black diagram in the same manner of earlier. The black diagram and two table of decimal to BCD encoder are shown below. So the black diagram. So here number of inputs are 10 inputs and number of outputs are 4 outputs. Those are A0, A1, A2, A3. Its respective two table is now see. The respective two table. The inputs are starting from Y0 to in sequence up to Y9. And the respective outputs A0, A1, A2, A3. So now inputs are like this way, starting from Y0 to up to Y9 and the respective binary code of those inputs. Now from these equations we will get expressions for A3, A2, A1, A0. So those equations now see, A3 is active high for Y8 or Y9. Y8 or Y9. Similarly, A2 is active high for 4, 5, 6, 7. A1 is active high for 2, 3, 6, 7. A0 is active high for 1, 3, 5, 7, 9. Okay. So now those expressions are shown at here. From these expressions, now we will go for the respective. The same concept can be extended for some other encoders also. Okay, so up to now we verified for maximum number of inputs and less than maximum number of inputs. Then we will discuss about some uses of encoders in our digital electronics. In general, encoders very easy to use in all digital systems. Okay, used to convert a decimal number into binary number. So we observed regarding to this one that decimal to binary. Next, the objective is to perform a binary operation such as addition, subtraction, multiplications, division, etc. Other applications, especially for priority encoders, may include detecting the interrupts in the microprocessor applications. So here, that about priority encoders, up to now we don't know. So I will make a video on that priority encoders later. You can watch about that priority encoders. It have some advantages over normal encoders. So anyway, what are the drawbacks of that normal encoders? In coming slides, I will discuss. Next, advantages of encoders. Reduction in the number of lines. So that means we know the number of inputs are 2 power n and the number of outputs are n. So that means the reduction in the number of lines. The same thing from multiple inputs to a single output, which can simplify the design of the system at the same time and reduce the cost of components. So that is the first advantage. Next, second one, improved reliability. So whenever the number of inputs lines are reduced to less quantity, then reliability of the serial transformation is increases. The same thing, by converting multiple inputs into a single serial code, encoders can reduce the possibility of errors. If errors are reduced, then reliability is increases. Possibility of errors in the transmission of information. Next, third one, improved performance. Encoders can enhance the performance of digital system by reducing the amount of time required to transmit the information from multiple inputs to single output. So because of this, that performance is increases. Okay. So next, not only advantages, there is some crucial disadvantages with that encoders are there. Those are listed at here. Increased complexity, more complex circuits compared to multiplexers and require some additional components to implement. Okay. Next, limited to specific applications only. Only suitable for applications where a parallel set of inputs must be converted into serial code. So that is second one. Limited flexibility. So encoders are limited in their flexibility as they can only encode a fixed number of inputs into a fixed number of outputs. Okay. So up to now we discussed some uses of encoders, advantages and some disadvantages. Finally, the ultimate choice is depends on the user. So that is here simply discussed. In conclusion, encoders are useful in digital circuits that have their own advantages and disadvantages. The choice of whether to use an encoder or not depends on the specific requirements of the system and the trade-offs between complexity, reliability, performance and cost. Okay. So that these are the things. Some crucial drawbacks of that encoders is there is an ambiguity when all outputs of encoder are equal to 0 case. So we already observed if it is a 3 input encoder, so inputs are y0, y1, y2. So totally like that 7. If all 0 case is there, then the corresponding binary is represented like this: A0, A1, A2. Sometimes we don't want anything. So that nothing case and all 0 case is somewhat intermixing. So that therefore that ambiguity is appears at here. Okay. Next, second one, if more than one input is active high, then encoder produces an output which may not be the correct code. So we observed so many things, so many examples. In those examples, always only one of the input is active high. So in general, in practical, due to some mistakes, if more than one input is active high, then the output may not be sure the correct code for that one. So that is the one of the severe drawbacks in that normal encoders. Okay, whatever that drawbacks discussed in normal encoders, those are overcome in priority encoder. Priority encoder. Okay, so I will make a video on that priority encoder. Okay, so for that one, all of you can watch that one. Okay, so anyway, thank you for watching. So I am going to be signing off. Thank you, Ananda.